Welcome to our session on the binomial distribution. This is a model in statistics where we want to affix successes which have an independent binomial trial. So bi means two. So there are usually two possible outcomes when we are dealing with a binomial distribution. It has a number of properties or characteristics. Number one, there should be two possible outcomes. Number two, there should be a fixed number of independent trials. Number three, there is a success and a failure. Number four, the events occur independently. And lastly, these events have equal chances. So the parameters, like I've just mentioned for a binomial, are such that they have what? A named number of trials. The n is given in short. So you're given n, and you're given p, probability of the successes. So it follows the probability mass function, which gives you our following formulas to take note of. The mean for a binomial distribution is given by n times p. The variance for a binomial distribution is npq. The standard deviation for a binomial distribution is the square root of npq. And the formula for the actual binomial distribution is given by combination of n combination x times p to the power x q to the power n minus x, where p is the success and q is a failure. So q is the difference between 1 and the p. So if p is 20%, q is 80%. P is 10%, this is 90%. Now, let me teach you how to calculate the binomial distributions or the combinations. So combinations are there on a calculator, but I'll teach you using the non-calculator way. You start with what is called a Pascal triangle with 3 ones. So you add 1 plus 1, which is 2. 2 plus 1, 3. 2 plus 1 is 3. You close there. 1 plus 3, 4. 3 plus 3, 6. 3 plus 1, 4. Then you close with the 1 there. You also close the 1. Somebody help me. What do we have here? 5,
5,
10, 10, 5. Then you close with the 1s. Then 5 plus 5, or 5 plus 1, 6. Then here we have what? 15,
10,
20, 15. You're just adding the answers and putting them in the middle, in the gaps. Then you close. Then here what do we have? 7,
7,
35, 35, 21, 7. You close with the 1s. Anyone behind without I'm drawing the Pascal triangle? So you have 3 1s there. 1 plus 1, 2. Then my upper 1 plus 2 is 3, A3. 2 plus 1, 3. You close with the 1s. My number foot up. 1 plus 3, 4. 3 plus 3, 6. 3 plus 1, 4. You close. 1 plus 4, 5. 4 plus 6, 10. 10, 5. Close. 6, 15, 20, 15, 6. You close. 7, 21, 35, 35, etc. Of course, I'm just trying to make life easy for you. When you're given a combination, for instance, 5 combination 3, I up the 5, you count 3 times. 1, 2, 3. So the answer is 10. This one can also be written as follows: n combination r. So 5 combination 3 sometimes can come as follows: 5 combination 3. This is another way of a combination. 10. So tell me, what is 7 combination 4? 7 combination 4. What answer we get? You can see there. Anyone?
35.
Yes, 35. 7 combination 0 is 1. So this is 0, 1, 2, 3, 4. So in number combination 0, you can see is 1. In number combination itself is 1. So 7 combination 0, so 7 combination 0. This is 7 combination 1, 7 combination 2, 7 combination 3, 7 combination 4, 7 combination 5, 7 combination 6, 7 combination 7. So a number combination itself is 1. The second last number is itself. So 7 combination 6 is 7. 7 combination 1 is 7. So anything combination 1 is itself. So 6 combination 1 is 6. 6 combination 5 is 6. 6 combination 0 is 1. 6 combination 6 is 1. So this is 0, 1, 2, 3. So this is 6 combination 3. All right. But if you don't want to boggle your mind so much, you can use a calculator. And the most basic calculator is the Casio calculator. So those of you who have a Casio calculator, even Sharp is okay. Let me start with the Casio calculator. So a Casio calculator or Kenko, all of them are in the same family. It should look something like this. So if you want to calculate 5 combination, 5 combination 3, you press 5 combination somewhere here, and 3, then equals. What are you getting? 5 combination 3?
10.
10.
Pardon?
10.
10, correct. How about 7 combination 4?
35.
35, correct. So now this will help you if you have a big figure 10 combination 3. You don't need to draw the Pascal's triangle. What are you getting?
120.
Are we all following? How many have the Sharp calculator? Do you all have the Casio calculator? All right. So if that has been understood, I can proceed. So this is just a foundation for you to understand the genesis of binomial. Without understanding this component, it is difficult. It's elusive to comprehend. Okay. All right. Any questions before I proceed?
Collins, just repeat how you were getting the combinations without using the calculator. I think I missed that step.
You have 1, 1, 1. You add 1 plus 1, it's a 2. 1 plus 2, we have a 3. 2 plus 1, we have a 3. You close with 1 there. 1 plus 3, we have 4. 3 plus 3, we have 6. 3 plus 1, we have 4. We close with 1. Are you okay with how to come up with the Pascal's triangle?
Yes, yes. I think what I mean is the
The combination.
commission. Yes,
Combination for just
without using the calculator.
So you just go to this triangle here where there's 7. So 7 here, you start counting 1, 2, 3, 4. The answer is 35. 7 combination 5. You go up at the 7 up, and the next number should be a 7. 1, 2, 3, 4, 5. So the answer is 21. So what is 5 combination 3? You look for 5 after a 1. So our 5 is this one here. Count 3 times here. 1, 2, 3. So the answer is 10.
Okay, thanks. I got it.
5 combination 0. Any number combination 0 is 1. So you have 0, 1, 2. So this is 0, 0, 0 for everything. About 5 combination 5. Any number combination itself is 1. So 0, 1, 2, 3, 4, 5. So we have a 1 there. So it's also 1 there. So 1 there. You get it now?
Yeah, thanks.
All right. Are we together? Anyone else who's behind before I proceed? Now, for binomial, it's one of the easiest distributions as well, except people don't just understand. If you're given always two things. N is what? 10. P is 20%. So they ask you to find 5 things. A, find the mean, find the variance, and the standard deviation. B, and the probability x is equal to 0, and the probability x is equal to 1, and the probability x is equal to 2, and the probability x is equal to 3. Then you're also being asked to find the probability of at most 2. Then also at least 2. So here it's English that you need to be very particular with. All right. So how did you say the mean is? How do you find the mean? Who remembers the mean is what? Under binomial. NP. Our N is 10. Our probability is 0.2. By the way, if P is 20%, it's the same as 0.2. Do we agree?
Yes.
So meaning Q should be the remainder. It's 1 minus P. So if P is 20%, Q is the remainder. What is the remainder from 20%? 80%, which is 0.8. If here there was 20%, there should be 80%. Or 0.8. If there was 10%, there should be 0.9. There was 30%, 0.7. You get these, here they complement each other, right? So here our mean is n times p, which is 0.2 times 10, it is 2. Our variance is npq. So what is our n? 10. Our p, 0.2. Our q, 0.8. When we multiply these ones, we're going to get what? 1.6. Then our standard deviation, the square root of the variance, which in this case is npq. So what is the square root of 1.6?
1.26.
1.26. Okay. So this is how we find the mean, the variance, and the standard deviation. Okay. So now we go to the second part of the question to finding the probability of 0, 1, 2, and 3. Remember, I said the binomial distribution formula is given by the combination n against x. Then here you put the p to the power x and the q to the power n minus x, the difference. So here our n was what? 10. Our p was what? 20%, 0.2, meaning our q was what? 80%. Our q was 80%, which is 0.8. So the probability x is equal to 0. So you have 10, combination 0. Our p is 20%, or 0.2. Our q is 80%, 0.8. So the 0 comes on top of this guy. The remainder 10 minus 0 comes on this guy. The 2 must add up with the top guy there. Before we evaluate them, I just want you to understand the format. Suppose there's 1 there. It's 10 combination 1. And here we have 20%. And here we have 80%. Times. Where does the 1 go? On top. What number do we have here? The difference. 10 minus 9 minus 1 is 9. When I add these two, am I getting 10? Yes. The ladies help me. X is equal to 2. What are we going to write here? It will be 10 combination what?
10 combination 2.
Correct. Then here we're going to put 0.2 times what? 0.8. Where does the 2 go?
The 2
On
goes
0.2.
On 0.2, correct. And here on the 8, what we put?
8.
8, correct, because the difference between these two. Lastly, the gents, x is equal to 3. What do we write? The guys, to be 10 combination what?
3.
Then here are 0 point what?
2.
And 0 point what?
8.
What comes on the 0.2?
3.
Correct. And what comes on the 0.8?
7.
Excellent. So now let's break down from what I've taught you. The other is just literal mathematics. In number combination 0, what did we say? 10 combination 0 is what?
It's 1.
1.
We abuse the calculator. 0.2 to n number to the power 0 is what? 1. So only you need to calculate is 0.8 to the power 10. What do we get? What is 0.8 to the power? I hope you know where the to the power is. 0.8 to the power 10. What do we get? 0.1073. Confirmed? Using a sharp calculator to the power is somewhere here. So the power is this arrow here. So you just do 0.8. Then this is the power what? 10. All right. So this is what we're getting, 0.1073. Then let's go to the second pairs. It's 10 combination 1. Any number combination 1 is itself. Remember, 10 combination 1 is what? 10. 0.2 to the power 1 is what? 0.2. How about 0.8 to the power 9? What do we get?
0.1342.
Okay,
0.1342.
342. What's the final answer we get here?
Zero point 0.0268.
Okay,
0.026. 8.
Are you sure? Not 0.26. This was 0.013 or 0.13. This is because this is as good as multiplying by 2. Because this is 2. Then just double that. Just confirm your answer.
Plus 0.1342.
Yes. Then you multiply by everything there. What do we get? Isn't it supposed to be 0.284?
0.2684.
Correct. Then here, what is 10 combination 2? I showed you in the calculator. 10 combination 2.
45.
45, correct. Then 0.2 squared. 0.04. And 0.8 to the power 8.
0.1677.
0.1677. That's the final answer. 5 times 104 times 0.1677.
0.3019.
19, okay. Then finally, what is 10 combination 3?
120.
120. 0.3, 0.2 to the power 3. 0.008. 0.8 to the power 7. 0.209
209.
or 210 or 0.97. So what's the final answer?
0.2013.
0.201.
2013.
Correct. So we find the probabilities of 0, of 1, of 2, of 3 using the binomial distribution. That to find the probability of at least or at most 2. At most 2 means 2 and below. At least 2 means 2 and above. So you need to understand those notations. So probability at most 2 means what? Probability of what? 2 or less. So this means we're starting from 0 plus 1 plus what? 2 itself. Do you go to 3? No. At most 2 means 2 and below. So what was the probability of 0? 1073. You put your 1073 here. What's the probability of 1? You go to probability of 1, 2684. You put your 2684. What's the probability of 2? You go on the 2, which you get as what? 3019. 3019. Then you add them up. All right, so what do we get when you add them up? 0.1073 plus 0.2684 plus 0.3019. You get 0.6776. So this is the probability of having at most 2. Probability of having at least 2 means we're moving from 2 and above. So 2, 3, up to the last number, our n is what? 10. Now this will take the whole day. The shortcut is simply negating 1 minus the numbers before these 2. The sum of numbers before these 2. Which numbers are below the 2? 0 and what? And 1. This is the easy way out. I repeat, They have asked us to find the probability of at least 2. It means 2, 3, 4, 5, 6, 7, 8, 9, 10, which is a tedious procedure. So you just find, because we know that the probability of 0 up to the last number will give us 1. So the easiest way is to find 1 minus the probabilities of the numbers just below these 2. So here we have 0.1073 plus 0.2684. So this is what will give us a probability of at least 2. So in this case, 1 minus 1073 minus 2684. So we get 0.6243. Now you need to also understand that what determines when to subtract is the gravity, the gravity of the work involved. Since we have probabilities of our sample size from 0 up to 10, when they tell us at most 8, it means 0, 1, 2, 3, up to 8. It will take you the whole day to start calculating 0, 1 to up to 8. So the easiest way is 1 minus the unwanted. The unwanted part starts from 9, 10. So probability of 0, probability of 1 minus 9 and 10. That's the easiest way. You will negate the easier ones here, other than you doing probability of 0, 1, 2, 3, up to 8. But if they said at least 8 means 8 and above. So it's easy. You can directly go to 8, 9, and 10. Just add them up. It's not always that when you hear at least you subtract. No. You see where the work is more. All right. Sometimes you may have only 4 sample size and they say at least 2. Means 2, 3, and 4. It's okay. Or at most 2. It means 2 and below. 2, 1, and 0. You add them. So you need to understand the grammar that is there. If they say no more than 2, means what? At most 2. No more than 2 means 2 and below. No less than 2 means 2 and above, the same as at least. But if they said find the probability more than 2, we're starting from 3, 4, up to 10. So you're not including the 2. So in the unwanted list, we have 0, 1, and 2 itself, because the answer or the question is asking for more than 2. Prerequisite for this course is English. You should have passed grammar English to understand what I'm talking about. Are we together?
So if they say less than 2, we're talking about 1 and 0 or 0 and 1?
Excellent. Less than
Okay.
0 and 1. All right. All right. So this is how binomial distribution is supposed to be done.